Hey, Mark.
Yep.
Morning, Jacob. Morning, Mark.
Nice background.
Oh, thanks. Got my power armor sitting, waiting for me. Go kill some raiders later. Mark was here for a second.
Yep.
So Jacob, is this Jacob Gross or Jake?
Gross.
Okay. I can never remember which one is which, and which of you has their full name on the screen. Did you play around with it at all last night?
A little bit.
Any issues or anything?
Not on my end.
Okay. Cool.
I have a little bit of previous experience with Solidworks, stood to a class.
Oh, did you? Oh, okay. How far did you guys get in like covering stuff?
We got to the assembly and the stuff for now.
Okay.
Cool. It was a Solidworks class at community college.
Oh. At what? St. Louis Community College?
Rivers in Washington.
Oh, okay. Was it like a credit class or just like a?
Yeah, it was GET designs kind of thing.
Okay.
We didn't do any Mastercam. It was just Solidworks and drawing up stuff.
Yeah. Well, and this part should be pretty easy for you.
Yeah.
Well, dang, I wish Mark was here because I actually have some news for him. It'll save me an email.
Yeah. I also did a lot of inventor in high school.
Oh, okay.
That's fun.
How'd you manage that?
Just took 2 drafting classes for fun.
Okay.
We had on the roof power generator wind turbine one. So for a side project, the teacher had me just draft it up, get all them in inventor.
Oh, nice.
The turbines are really harsh to make because you had to make a hole right on the tangent of a circle.
Yeah. Yeah.
I just cheated, made some flats.
Mm-hmm. Yeah, sometimes it's just kind of creating some extra geometry in there to make everything stick together. Mark, can you hear me?
Yes, I can.
All right, great. So I just got an email. I just clarified with Jason Hug from IT, and he said he should have a laptop ready for you tomorrow. What did he say? Let me find the original email. After 11:30 tomorrow. So if I hear anything back from him, I'll give you more information. So when I had to go pick up my computer, basically he left it with the security in the Walker Hall.
Okay.
So like if you just go in the, you can park on page, go in, bring your badge, they'll get you in, and then just say, hey, I'm Mark Schneider. I should have a laptop here. Before you head down there, I wouldn't head down there unless A, it's really close, and I don't think it is, or B, you hear something from me or from Jason Hug, who's the or Miwa Singin. I don't know how you pronounce her name, but anyway, I wouldn't head down there unless you hear something. But so what they're with the laptop, they can't install Mastercam and Solidworks on the computer because you have to be on the network to get the license. So what you're going to have to do is they're going to set up so you can install the home learning edition. So you'll be able to install the home learning edition of Mastercam and SolidWorks. So, all that information is in the emails that you have. Well, hopefully, do you still have those emails?
Yes.
Okay. I don't ever delete an email. So I just assume everybody else does the same thing.
Rankin deletes them after like a semester or something, which drives me nuts because I had my.
Do they really?
In there, yeah. I had my resume in there at one point and they deleted it. So I had to rebuild my resume.
Like just deleted everything with no warning? Man, that sucks.
Hey, Mark.
Yeah.
I got one of those computers from Rankin too. I would recommend doing all your downloads at Rankin.
Okay.
Yeah.
Because as soon as I brought it home, it couldn't access the internet at all.
Oh, neat.
Well, I mean, you're going to have to connect it to your Wi-Fi, obviously.
I tried it.
Oh,
Once it's on Wi-Fi, it wouldn't even let me bring up Google or even the Rankin site.
really?
Oh,
Yeah,
that's cool. That's
Not.
pretty much. I just been transferring everything to Mastercam and back with a flash drive.
Okay. Yeah, you might want to shoot help desk an email because that sounds pretty screwy. I mean, you should be able to connect to any Wi-Fi network with that laptop. There shouldn't really be any. Not that I can think of. There shouldn't be any like sort of permissions or thing that should make that not work. So I mean, unless it's not bothering you.
It's not really. I just
Yeah.
save it to a flash drive.
Okay.
Transfer it to U drive on my personal computer.
Yeah. Okay. I mean, if that works for you, but yeah, Mark, if you're having that issue, I would still get on the computer. You're going to have to log on the laptop while you're there, or else you will not be able to log on at all. But yeah, once you get that, I would probably go ahead and download it there anyway, because also I'm sure Rankin's internet's faster than your internet.
oh, guaranteed.
No offense.
No, none taken.
But yeah, I would still try to download everything from Rankin. And like when I went, I just went over and sat on a chair and at a table and downloaded all my software while I was there, just to make sure it all worked.
Gotcha.
So, all right. So let's get started with some SolidWorks, not Mastercam. All right. So right now I have, what we're going to talk about today is we're going to talk about assemblies. So we're going to go over just kind of the basics of assemblies. We talked a little bit about it yesterday. We're going to go into it a little bit deeper. So basically what we're going to do is we're going to make our offset boring head. So I already have my 6 parts drawn, 1 through 6. Materials already, determined and all that. So what I want to do is I want to start off with a part of this that is going to make the most sense as far as which part I start off with. Because if you remember from yesterday, whenever I create an assembly, the first part that I put in there, the first discrete part is going to actually become fixed. SolidWorks will automatically make it a fixed component. So that's kind of something to keep in mind while you're, when you're putting these assemblies together, because like this, part number 1 actually slides back and forth on part number 2, right? Or vice versa, depending on how you're looking at it. With this, because it's a tool, one of the things we can kind of think about is what's the part of the tool that we hold on to, right? So, it's kind of one way to think about it. If I think about what part of this I actually hold on to, it'd be the shank, right? So this is actually the part I'm going to start with in my assembly. right? So I have my parts, they're all fully dimensioned and everything. And so from here, I'm just gonna create an assembly. So I go up to new and make assembly from part assembly. So, come back to my templates. I don't have any templates for assemblies. You can make templates for assemblies. In my experience, for the parts that I have used, I really have not seen much use for it. So I don't typically do that. So anyway, so I'm just going to take part number 3. That's my shank part, and I'm just going to click out into the ether here. So right now, right, I have my shank part, and I know it's fixed because when I come over here, there's a little F in parentheses. So, right, that's my fixed part. And I also can tell that I'm not really looking at it from the top. Right, if I go to my standard views, my top view is going to be that, or front is going to be that view, top view would be somewhere else. I'm not really going to worry about that. It just kind of changes where the shadow is. If I don't want to do that, I can just get rid of shadows, right? That's just as easy as, actually easier than moving this around. If I did want to move this around, right? So say that really bothers me, right? So obviously, if I'm using this, my shadow light's going to be coming from the top, right? So my shank would be pointing up in that direction. So let's say I'm just really nitpicky here and I want to fix that. So all I really need to do is float this guy. So right now it's fixed and I actually want it to float. So floating just means that it doesn't have any constraints on where it lies in, in our model or in our assembly. So when we click float, it gets rid of my little fixed symbol there, and now I can drag this around wherever I want. So this in of itself, right, isn't really useful because I can move it, but it's still going to maintain its original orientation. So what I can do is I can right click this and move with triad. So triad is just a gnomon, right? It's just the XYZ. It's yeah, it's a gnomon. So with this, this should look very familiar, right? This is basically the same as Solidworks, or I'm sorry, Mastercam, where we can drag this around. Right, so I'm gonna undo that. I'm just going to get into a standard view just so it makes life a little easier for this. So now I'm looking at it from straight from the sides. So now when I go from here, 360 is where we are here. And then we're just going to go up to 270. All right, and so now that is, if this is the orientation I really wanted to present this assembly in, now I am aligned better, right? I'm aligned more how I want it to be. If I needed to turn that, I could still do the same thing, move with triad, and I would just turn it around that way. Not really worried about that. But anyway, you can do it, right? So anyway, but before I start throwing in models here, or before I start throwing in parts, what I want to do is I want to fix this. So this was floating, or was fixed. I made it floating, and now I'm going to make it fixed again. So again, I just right click and fix. Click on the fix button. Yeah, I don't think any of those are fixed. All right, so now, and the reason I want to do this is because, well, I'll show you in a second. So, all right, now I can kind of start throwing in parts, right? So part 1, I'm just gonna drop in there. Now, since this is the second part, I look in my feature manager, this does not have the F, so this is free floating. I can drag this wherever I want, literally, because it's not even gonna detect any sort of collisions. It doesn't really treat these like solid parts until I tell them to. and really, it's not actually that useful of a tool in SolidWorks. It sounds like it would be, but it's really not. All right, so so I have parts 1, 2, and 3. So I can add these in individually, or if what I can also do is do a control click. All right, so I can click all 3 of those. And now since all 3 of those are highlighted, I can click. Each time I click, it's going to drop the successive part in. All right, so now I have an assembly that is not assembled, right? Not super useful. Well, from here, it's basically kind of putting this together like we would if we had these parts in our hand. So, you know, we got it's kind of like, you know, the skeleton song, hip bone's connected to the leg bone and all that stuff, right? So really, we're just going to go down the chain and put these parts together. So when I look at this, I need to figure out, well, how does this assemble onto here, right? So obviously, it's going to need to turn. And when I started out doing this, I was just kind of figuring it out on my own. And this is one of those things that I actually really struggled with for a while, is how to get these parts on here. So the good news is we can kind of just look at the geometry and figure out what this is, right? Or how this is going to fit together. We have a boss on here and a hole here and a whole circle, right? So that hole goes in, or I'm sorry, that boss goes in that hole, and these holes line up, right? So all we're going to do is we're going to select that part, and then we're going to use this little paper clip guy. So that is our mates function. So the mates function is kind of like, or is very, very similar to relations, right? And actually, it's the same thing. In fact, when we start getting into this, you'll see a lot of the same concepts, right? So we're going to have perpendicular, we're going to have parallel, we're going to have coaxial or collinear. So we're going to have all these terms that we've kind of learned over the past couple of years, or have learned in blueprint reading or whatever, or GD&T, right? So some of these terms are going to kind of come back, so the concepts and all that. So it's pretty straightforward. All we're going to do is we're going to select the segments that we want to mate these together with, right? So what's going to determine where this is located in, well, if I look over here in X and Z, right, which is going to be moving across this face, forwards and up and down, left and right. Well, if I do a mate with these two, if I make these coaxial or concentric, that's going to line them up, right? But as you can hopefully tell, we can't really violate the laws of physics in class. So what we have to do is we have to flip this around. And that's what this little button, this mate alignment, is. So what's going to happen is it's always going to satisfy this constraint, right? So we're making these two cylinders concentric. It's going to keep these cylinders concentric regardless of whatever else I do. I can still move, I could still, if I make these concentric, oops, if I make these concentric, one more time, there we go. All right, if I make those concentric, then I can do all sorts of stuff, right? I can still rotate this. I can still move it up and down because that concentric rule is still being followed, right? So it's going to force me into following that rule, but I'm not telling it everything, right? So this is kind of like our datum references, right? We have one datum reference here that's saying location as far as where I'm going in along this plane, up and down, left and right, but it's not determining anything about where this is in Y right now, right? And this is Y. So that obviously is not lined up how I would like it to be. So all I really need to do is change my alignment, and that's what this button is going to do, right? So it's going to keep this concentric constraint, but what it's going to do is change how that constraint is met, or what direction that constraint is met, right? So we're going to keep that guy. So now we're at least in the right physical orientation. And then from here, I like to use 3 mates in order to connect parts together. I kind of think of it as XYZ. Sometimes there are ways that we could do this with less than 3, right? So we're already located in one axis or 2 axes in our direction or where we are, but our third axis is up and down. And so what we're going to do is we're just going to make this surface coincident with this surface, right? So coincident just means that those 2 parts are occupying the same space, right? So coincident is really useful for, well, coincident is really one of the ones you'll use more than anything, but you know, it's great for fixing 2 surfaces together or 2 lines together, something like that. This is kind of like gluing this part together. So what we might be able to do is use these holes to line this up, right? It's like if these holes were exactly the same size, I could possibly use a coincident with that and that. Instead of using the cylinder, I could possibly use the whole edge. But again, that's not really how I like to do it. So in this case, what we'll do is we'll just create another concentric mate, right? So we have all of our linear axes. We don't have any freedom of movement, right, in our linear axes, but we still have freedom of movement in a rotational axis, right? So how do we get rid of that? Well, there's a variety of ways. We could use our holes, right? I could say I'm going to make this hole concentric with this hole. Right? And as long as my hole locations are correct, that mate can be satisfied. But if this hole location is off even like 100 thousandths of an inch, it won't let you do this. So these holes have to be sized perfectly, or not sized, but have to be dimensioned perfectly. So if they do not match up perfectly, you will not be able to do this sort of mate. But usually it works out pretty well, because usually these bolt hole circles are a nominal number and all that. So for us, it does work. But let's just say for some reason it didn't. Maybe this part that I got, maybe I had imported a part from a different manufacturer and their model's just a little bit off. You know, maybe it's conversion error or something like that. So I wouldn't be able to, oh, here, I'll just actually, how about we do this? I'm just going to open this part real quick. I'm going to go in here and I'm going to edit this bolt hole circle. So I'm going to change this bolt hole circle diameter from 1.5 inches to 1 inch 501 thou. All right, so now that bolt hole circle is off by 1/1000th of an inch from our mating bolt hole circle. And as a second year machinist student, you should know that this should be fine, right? In the real world, there's nothing wrong with this, right? We have 30 thousandths of clearance in this hole. So this bolt hole circle being 1 thou off is not going to do anything. But if I try to do this mate now, and don't make a liar out of me. Oh, it let me. What the heck? Oh, wait. Did I save that? Maybe I didn't save it. This really shouldn't let me. This is disappointing. Let me do this. All right. Huh. Well, used to not let you do that. Anyway, so that does work apparently. Apparently it has some error now, some error allowance. But let's just say that didn't work, right? Well, we can also infer from these parts another way that we can line this up, right? So if I wanted this, I could just say this side is going to be parallel, or that side of my part is going to be parallel with my flats, and that will line these up as well. You have no idea how many times I fought that. This is why I'm like almost having like kind of a hard time believing that actually worked, because I've had to fix hole alignments because they were off by less than 1,000th of an inch before. Spent a decent amount of time doing that. So apparently that's a update that I wasn't aware of. All right. So anyway, these two parts now are fully defined, right? And easy way to tell that is if I try to drag this. I can drag parts that are not fully defined or underdefined or not defined at all. But if I try to drag a part around that is fully defined, you should be able to see, well, hopefully you can see that there's a little dialog that pops up that says select the component is fully defined, it cannot be moved. All right, so that's what I'm looking for. I want all my parts to be fully defined. I'm going to change the material on this so it matches. There we go. Side note, I know I kind of talked about this before. These two parts aren't on your prints. They are not called out as being a specific material, or they are, but it might be cold rolled. I have a lot of students make this shaft out of brass, and I don't have any problem with it. I actually think it's a good way to go, brass or bronze or something like that, because when it runs through this, you'll have a much smoother motion. It won't be quite as durable as if both of them were steel, maybe, but yeah, who knows? All right, anyway, so we're gonna keep on moving. So at this point, let's just go ahead and I'll line this guy up. So this guy's going to attach to this hole here. All right, so before this, the shank is attached, a bolt will go through here and attach this guy. So on this point, we're just going to do a mate with that hole to that hole. All right, it automatically lines that up. So again, I have a concentric mate. I still have rotational freedom, and I can still move up and down. So I will just mate those two surfaces. And you don't necessarily have to select a mate lots of times. Usually it will look at what you're selecting and kind of try to figure it out. Right, so here's probably a better example of using a parallel mate, right? So I don't really have any way of saying this is going to be straight, right? I can't say this is going to be coincident with that, but what I can say is this side is going to be parallel with that side. Oh, you hit the mate button. All right, so I click those two sides. Well, it can't make them coincident because of the other mates constraining this. I can't be perpendicular because of the other mates constraining this. So what it's going to do is it's going to go through here and it's going to kind of use the process of elimination and help you out and figure out what your most likely mate is, just like a dating app. All right, so then we are going to, so hopefully you can see why this is not how you'd actually assemble this in real life. Because you're going to have a really hard time getting that dovetail in there at this point. So when we actually make this nut goes in that slot. Oops, that's not what I wanted to do. So this nut would go in that slot, and then you would put this in the dovetail, the slide in the dovetail of the base, and then put the screw in and hold it there. But we don't need to obey the laws of physics today. So what we're going to do is we will just, I believe it's that one, isn't it? So actually, let's just do it that way. We're going to take that shoulder and we are going to make it coincident with that. So because we have two planes that are coincident, right, basically I have a plane defined by that rectangle and a plane defined by that rectangle. So when I have these two planes, right, it's going to make a coincident mate. And as you can see, I can still drag this around if I come here, right? I can move this around anywhere I want, but it's always going to keep these two sides on the same level, right? So it might look like I'm dragging this down, but I'm really just changing the position of it to the point that it disappeared. There it is. So that's actually a good tip. Right. Sometimes you'll do, you'll be trying to move something around and you get to your part and you're like, oh, what happened to that guy? Where is that part? Well, it's still here. I can see in my feature manager tree that I still have 1, 2, 3, 4, 5, 6. Well, just like in Mastercam, this zoom to fit button is going to zoom us all the way out, and then we can try to drag this back to a more reasonable location. All right, now we still have 6 parts. All right, so like I said, all we're doing is getting there, and so now I'm just going to, we're constrained as far as where we are going in up and down, but we can still move back and forth, in and out, back and forth. So we're going to go back to this guy, but instead of selecting this shoulder, I'm just going to select this line.
Mr. Durkee.
Yeah.
Why wouldn't you just make the 2 holes coaxial?
You mean this hole and this hole?
Yeah.
You could.
I just feel like it would make sure everything's lined up for next parts.
Well, we'll try it, but I'm actually think that these don't line up. Possibly. No, they do. No, they don't, because it just made those parallel. All right, so let's delete that. We're gonna delete that. All right, so let's go through here, and if I try to make that coaxial or concentric with that, all right, it's gonna switch to a parallel, and when I try to do concentric, click OK. So the selected mate could not be successfully created. What would you like to do? All right, so the reason why is because this is how, well, here, I'll show you in a second. So I'm just gonna mate this how I was kind of moving down that way. Well, actually, I'm gonna back up. So just to answer your question a little bit more fully. All right, so that guy's there. So in order to do this with the concentric mate, I still have to have another mate, right? Because this is now I'm locked in on a rotational. I can still rotate around the axis, and I'm locked in along the z-axis, but I can along X and Y, but I can still move in Z. So I'd still need to have some sort of parallel, type mate, just to keep it where I want it to go.
Yeah.
Here, we'll switch to there. And now when I look at my part, I need to switch to, that's weird. Why? So if you look, right, between these two parts, because I'm going off of this, now I have interference. So I have about 7/10 of interference here and 7/10 of interference here. So that's what I was talking about a minute ago, is that these actually don't line up perfectly. So if these are 7/10 off, right, that's not a whole lot, but it's enough for Mastercam to kind of throw a fit. We can also determine like how far apart these are. So I'm just going to change. So the measure tool, I talked about it really briefly. It's not real useful. I mean, it is useful, but it's not super useful in just individual parts. But when you start getting into assemblies, that's really when it gets to be significantly more useful. So in your evaluate tab or evaluate ribbon, there's a measure button. It just brings up a little tape measure, ruler, pointer, right? So in order to do this, we can click on individual components and it will give us information about that, right? It'll tell us the area and perimeter of that shape, stuff like that. It'll tell you the length of a side. You know, if you select two components, it'll tell you how those two components are related. Like those items intersect, it has 125.26 degree angle between them, all that fun stuff. We can also use it to see what kind of clearance we have. So if I click on this surface and then I click on this surface here, right, it'll tell me how much clearance I have. Now, right now it's saying I have 0 clearance, but obviously there's a gap there. And the reason why it's saying that is because it's only going to 2 decimal places. So if I click on this inch mm button, it's going to change my units of precision. I can use a custom setting. I like to do like 5 decimal places. All right, so we have about 3.5 thou clearance in between these two parts. So when these are lined up, we have interference there and clearance there, which is not actually how this part would be. So that's, I guess that's another answer as to why I did it this way, is because this is really not how these parts are going to fit together, right? This isn't going to determine where this hole isn't going to determine how well these parts fit together. What's going to determine that is the how well these dovetails fit together. So I'm going to get rid of that guy and I'm going to get rid of that guy. And so also what can seem like the easier thing to do is just say, all right, well, if I know that line, if I want to make that coincident with that line, right? Again, this is how I used to do it. I used to think, all right, well, I'm cool now. Well, I'm not really, because all I'm doing is saying that those two axes, those two lines are going to be coaxial. I'm not saying anything about the rest of this part. Now, all I need to do to fix this as far as how it's going to be is to create 2 parallel sides. But now when I look at that, now my dovetail is more aligned. Because, and I guess the biggest reason why I say I like it this way is because then I can use my evaluate tools, right? I can see how well these 2 parts what the heck? All right. Okay. All right, so I can look at that and say that these hole locations, well, it says it's fine. But I can also use my evaluate tool. Might be a better way to do it. And if I take that cylinder, right, and that cylinder, those two cylinders should be coaxial. And what I actually have is a distance of 3 inches or 3 thou and 7/10, which is what, you know, our interference was on this before. So at this point, I could go in, I could start moving this hole around to maybe get it aligned better. And maybe we'll talk about how to do that. I'll write that down. All right, so we're just gonna keep on moving, keep on trucking. So we have 4 of our 6 parts. So now I'm just gonna go with this guy. This is the easiest one. So with this, I'm just gonna say this is going to go, that's going to go on this face. Oops. And then I'm going to make that coaxial with that. These in. And then this guy is going to go on top of him. And that surface goes to that surface. And I'm just, and again, we can still rotate that around. So I'm just going to create that parallel with the bottom of my part to lock it in position that way. So now on this part, those little notches might make a little bit more sense, right? So they're just there to create clearance for that dovetail and so on. And also I can see my hole locations for this guy. One of these is going to be off. All right, so I'm going to save this as a, well, it's going to want to rebuild. I'm going to save this as my assembly. All right, so that's all fine and good, right? So this does allow us a lot of benefits, right? I can look through this model and I can say, you know, am I running on a, you know, am I having clearance issues? Is this the right part for this assembly and all that? So as you can imagine, if I was prototyping this, if I was just creating this for the first time, I can really save myself a lot of time and effort, money, and all that by designing this in here, being able to see these changes, being able to quantify the changes too, before I actually start machining anything. But another benefit of the assemblies is being able to do bills of materials. And so the first step to being able to do that is actually using the toolbox. So Solidworks built into it, and sometimes you have to add it, has to be like an add-in, which Solidworks, instead of saying extensions or plugins or something like that, it just calls them add-ins. And so these add-ins are just, sometimes they are made by Solidworks, sometimes they're made by other companies, and they're just basically little tools that you can use for different uses. So there's actually the add-ins ribbon over here, and these are all different add-in functions, right? So CircuitWorks would be if you need to do circuit diagrams, like layout electrical circuits. PhotoView is going to be a rendering type thing. Scan to 3D is a 3D scanning tool. SolidWorks Motion is motion analysis, so you can put your parts in motion and it'll kind of show them, do things rotate It's how you expect them to. Do these components actually connect together how you expect them to? Solidworks routing is for electrical and plumbing routing. It's like if you're making, you know, a large schematic of a machine and you want to route your wires through it, that's what the routing for. Simulation, SolidWorks simulation is uses like physics-based tools. So you can do stress analysis on your parts. You can see, you know, if I have this in a rigid holder and I push this to the side with 200 pounds of force, how much is this shaft going to bend, right? How much is this tool going to be displaced? That's actually one of the coolest parts. It'll take, because it uses your materials, right? That's why we give it a material designation. It'll use your material numbers to figure out what that is. SolidWorks Toolbox, that's the fasteners and stuff. Towel Analyst is like a GD&T tolerance stacking analysis tool. So it'll look at your model and figure out, is this tolerance correctly? Is it fully toleranced, right? Are we using broken chain, you know, full chain, whatever tolerancing? Flow simulation is going to be like any sort of fluid. So fluid means air or water. So we can do drag analysis on our part, see how much wind resistance our boring head gets when it's going at 100 miles an hour. SolidWorks Plastics is like a it's like an injection molding sort of deal. It's kind of like flow simulation, except it's specific to plastics. And then inspection incorporates CMM type inspection stuff. And I am not sure what MDB SNL is. It's the SolidWorks Saturday Night Live version. I don't know. It's funnier than I am. Some days. So anyway, what we're going to do is we're going to use the toolbox. So if we go to Design Library over here on the right, so we have these little tabs, you know, have our resources. Also, I guess I haven't really talked about the resources tab. This is actually very, very useful. We got, you know, basically it's your help. It's like your help files. You can get in here. There are tutorials. You can do the community, wherever that is. Yeah, the discussion forum. It'll take you to the SolidWorks discussion forum, and you can, you know, find all sorts of information in there. So we got Design Library, File Explorer. That should be pretty self-explanatory. Our view palette, no, we don't have that. Appearances, so I can change the appearance of this. I can make it lighter, darker, shinier, more dull. Might get into that later. Custom properties, we can create custom properties for our parts. You know, like common custom properties are who drew this, who designed it, how many of these do we need in this assembly, that sort of thing. But what we're going to do is we're going to do a toolbox. So we're going to add this in, which is basically going to load the toolbox. And then we get a little drop down. So at this point, we have all sorts of different standards of parts. We even have some specific manufacturer parts, like SKF is a very big bearing company, so angular contact ball bearings and that sort of stuff. So it's pretty cool because you can actually go in and use standard library parts and use those. Like SKF is like I said, is a bearing company. These bearings are standard bearings. So, you know, the bearings have a model number on there, like 7206. That's a specific size and type of bearing. And so that 7206, yeah, I think it's 7206, is going to be the same regardless of SKF or a FAG or, you know, or whatever. It's going to be one of my favorite bearing names, but you know, it's going to be the same regardless of whatever the manufacturer is. So even though, you know, you might be making something and using bearings and they're not SKF, you can still use these SKF bearing models because it's a standard model based on the bearing size. But what we're going to use is the ASI or ANSI inches, right? So you can already see we have all sorts of different part types. We're going to go into bolts and screws because we're going to add some screws into this. All right, so one of the things I like to do is whenever I'm creating assemblies, I like to know how many screws I need to put in here. Because if you're like me, if you've ever done it, it's kind of a pain where you start putting something together and think you have everything you need, and you're missing 832 screw, right? You're missing that one screw that in order to get it done. So basically, we can go through. We have all sorts of different types of screw types. So we're just going to do a socket head cap screw, or socket head screws. So this is going to include button head, flat head, socket head, and shoulder bolts, or stripper screws, depending on whatever you want to call them. So from here, it's just really drag and drop. So if I drag this over here into that hole, and then unclick, so I had that my mouse button depressed that whole time. Well, now it automatically drops a fastener in there. For some reason, it always defaults to the fine thread. Not sure why, because fine threads are a heck of a lot rarer than coarse threads. So from here, what I like to do, or one of the things you can do, is make hidden lines visible. And so now I can see into my part. All right, so now that I can see into my part, I can actually drag this to determine how much of a thread I need. So does anybody remember how deep, what's the max, or not the maximum, but like what's the optimal thread depth to go into a part? Anybody remember?
Sorry, what was the question? The cat.
So like length of thread. So like you have a screw going into your part. Like what do we usually shoot for as far as how far that thread goes into our part?
Isn't it like 2 times the diameter?
Well, that's usually how deep we tap a hole. And then
At least 1 time diameter.
Yeah, it's 1.5 times the diameter. So for a 1/4 inch bolt, we're talking about 3/8 of an inch. So as I drag this, it's going to click to whatever standard fastener lengths I have, right? So you're not going to find a 9/16. Well, actually, maybe you will. You're not going to find a 13/16. How about that? 1/4 20 socket head cap screw, right? Nobody, well, maybe somebody makes them, but they're probably incredibly expensive, super overpriced. So we typically want to try to use standard sized fasteners, right? And we also want to optimize those for how deep we're going in there. So when I drag this in there, I can see when I'm at 3/8, well, my thread isn't even in my mating part yet, right? So if I need that, if I know that needs to go in another 3/8 of an inch, I'm just going to go up to 3/4 and click OK. All right, so now I have this little checkbox here down at the bottom. So once I click that, what it's going to do is it's going to allow me to drop that same fastener wherever I need to. So what it's doing is it's saying, all right, this is the size of screw that I need for this one hole. And now, once I click OK, keep going around and plug in these holes with screws. Right, so I just click on one. I'm going to click on the face of that counter bore. Typically need to click somewhere in that hole. All right, and so that's the last 1/4 20 3/4 length screw that I'm going to put in there. So now I'm going to click X. All right, and then over here, I have my 4 screws in my feature manager. And so another thing I like to do with something like this, is not necessary, but as you can imagine, when you start getting into larger assemblies with dozens of parts and dozens of fasteners holding those parts together, this can get pretty crazy, right? This feature tree can get pretty crazy. So one of the things I like to do with screws is to create subfolders. What is going on with that? All right, so I'm going to add to new folder. So if I highlight all those and add to new folder, then I can just say this is going to be my 1/4 by 3/4 socketed cap screws. And so now all those fasteners are in a folder instead of being out in the open. And so then from there, we would just basically do the same thing over and over again. So this is going to be a little goofy probably because this is a very non-standard hole. So we'll see how well it works. I'm going to do the same thing. I'm going to do hidden lines. I'm going to change it to 1/4. And from here, I'm just going to drag this in. So when I'm pretty much even there, I'm 3/4 again. So when do I want to go? Or 3/8 again. So I'm going to go 3/4. So apparently, could have done that both times. Could use the same fastener on both. So from here, I'm just going to again click on that, click X. And now, since these are the same size screw, I'm just going to go ahead and drag those into that folder. So now I have 6 socket cap screws in there. Oops. And so we'll just do that again. So that's going to, same thing is going to be here, right, except we have a different size screw. Still, well, actually, I take that back. I think I got your button head cap screws for that. I think it looks better. All right, so 836. Wow, not familiar with that one. All right, so we're going to do 832. Pretty sure that's the whole size in there. And just going to drag that in. So we'll just say 3/4 as well. We'll click OK. Click OK. Why is that not working? Oh, there we go. All right, and then we have 3 more fasteners. So here, right, we're just going to have set screws in there. So we're going to go to same thing. We're going to go into our toolbox, ANSI inch, bolts and screws, and then we're going to go down to set screws, socket type set screws. And I believe that these are cut point. So we're just going to drag that to that hole there. And it seems like it always defaults to the wrong thread size. Oops, shit. All right, so messed that up. So I'm just going to undo it. So I clicked a checkbox before I actually made it long enough. Well, maybe, because if memory serves, these are really short. And same thing, just going to switch to hidden line view, and think they're 1/4 inch. So we're gonna click OK. Now I made that deep because it's not all, I mean, it's actually sitting inside that hole. So yeah. All right, well, that guy didn't want to go in there. So when you do your tool, when you do your toolbox, when you do your fasteners, this is probably going to happen at some point in time where you stick it in the wrong spot. Actually, we got a couple of things in the wrong spot. Like, that shouldn't be there. So what we can do, basically what happens when we do this is this doing a few things. One is figuring out how big the hole is, what size fastener you use, but it's also using, it's also mating this part in there. So like if I click on these screws, I can go down the, I can click here, right? It says mates and boring head assembly. So right now it has this as a concentric mate there. I'm going to delete that. And this is going to allow me to move this wherever I want. And so now I'm just going to remate this inside this hole. And there we go. All right, so now we have both these. I'm going to mate this to this guy just to so it'll look better. All right, then we have one more screw to put in this thing. So we talked about it before. It's the screw that holds this little block to our main body of the boring head. So you might be looking at it going, well, how in the hell do we get in there, right? So pretty easy. If we just hide that one component, that's going to give us a clear view into that hole, which is then going to allow us to connect it. So now I'm just going to do the same thing one more time. Socket head screws. And I'm just going to drop it down into that hole. Maybe. I can't remember. I believe that's a. So sometimes this does a really great job of selecting what screw to use. Other times it does not. So I believe that's a 1032 hole in that screw or in that block, but I don't know for sure. So an easy way to check that is if I click on that part, right? So that's part number 6. Well, in this feature manager, I can open up the tree just like I can if this was off on its own, right? So the feature manager here is going to match. It's going to have the same feature manager same feature manager options in here as it does for our assembly. Right, so in this case, I can just click on the arrow next to that part and I can look at it and say, all right, well, that is a 1032 hole. So I know that that needs to, I need to put a 1032 screw in there. It's not really figuring this out very well because this is kind of a goofy hole, kind of a pretty non-standard hole. So sometimes it has trouble with holes like that. But so I'm going to do is just come here, put it on that, and I'm just going to manually change my screw. I've tried fighting. I've done this before. I've tried fighting with it, and it's just typically easier to kind of take the path least resistance for this. But this is actually one of the more useful tools for us on this part, because it allows us to see how much of a screw can I put in there before I start running into this screw, right? So if I try to put a 5/8 screw in there, well, that's going to be interfering with the screw that makes the adjustments. Even if I put a 5 or a 9/16 screw in there, it's probably going to start touching. So I want to make sure that I'm using, a 1/2-inch screw or less. I'll click OK. I only need one of those. All right, and then I will just make that guy visible again. And there you go. So now we have a fully dimensioned, fully put together part in here. So like I was saying, one of the nice things about being able to use the toolbox and putting this stuff in there is that it allows us to make a bill of materials. So I think that's what we'll do tomorrow. We'll kind of talk about kind of troubleshooting because obviously there's a couple issues in here. So we'll talk about troubleshooting this and kind of figuring out where our issues are, in case you didn't know what troubleshooting was. So we're going to do that. We'll go over how to troubleshoot it, change hole alignments, and then we'll also create a print of this, maybe try to make an exploded view, and also create a bill of materials. So that's what we'll do tomorrow. Does anybody have any questions or anything that you'd like me to cover?
I think I'm good.
Okay. All right. Well, Mark, like I said, I think Paris Reese, actually I just got an email while
Yeah, I got a phone call while you were
Okay.
teaching.
Okay. That's probably Paris. So yeah, so she's gonna probably I guess she's already gotten in touch with you. So, but if you have any issues, please let me know, as soon as you do, so we can try to get them resolved.
Gotcha.
So, but yeah, if you guys don't have any questions, that's it for me today.
Okay.
Sounds good.
All right. Well, I'll see you tomorrow then.
See you tomorrow.
All right. Have a good one.